In this question from JEST 2019, we are given a wave function psi of x equal to a e raised to minus b square x square upon 2, and we are also given a condition on potential that v of x equal to 0 at x equal to 0. So in these types of problems where we are given psi and v and we have to calculate e, or we are given psi and e, we have to calculate v, we can make use of time-independent Schrödinger equation, which in one dimension is minus h cut square upon 2m d square psi upon dx square plus v of x psi is equal to e psi. So we need second order derivative of psi with respect to x. First, let's calculate first order derivative d psi by dx. D psi by dx is equal to a into e raised to minus b square x square upon 2 into derivative of minus b square x square upon 2, which is minus b square x equal to minus ab square x e raised to minus b square x square upon 2. D square psi upon dx square is equal to minus ab square d by dx of x e raised to minus b square x square upon 2. Now we can use product rule. So d square psi upon dx square is equal to minus ab square, derivative of x is 1 into e raised to minus b square x square upon 2 plus x into derivative of e raised to minus b square x square upon 2 is e raised to minus b square x square upon 2 into minus b square x. Now if you substitute back a e raised to minus b square x square upon 2 is psi. If you substitute that back, we will get d square psi upon dx square is equal to minus b square psi plus b raised to 4 x square psi. Now you can put this equation 1 in the time-independent Schrödinger equation that we wrote here. Then we will get minus h cut square upon 2m into b raised to 4 x square minus b square into psi plus v of x psi is equal to e psi. If you divide this equation throughout with psi, then you will get minus h cut square upon 2m into b raised to 4 x square minus b square plus v is equal to e. Now we are given a condition that v of x equal to 0 is equal to 0. If you put that, then here you will put 0 and here also you will put 0. Then what you get is minus h cut square upon 2m into minus b square is equal to e. This implies e is equal to h cut square b square upon 2m. In the option C and D, we are given e is equal to h cut square b square upon 4m. In the option D, e is equal to h cut square b square upon m. But we calculated right now that e is equal to h cut square b square upon 2m. This means that option C and D are incorrect. So E is equal to h cut square b square upon 2m. Now substitute this back into Schrödinger equation. So we have minus h cut square upon 2m b raised to 4x square minus b square plus v is equal to e. Instead of e, I will put h cut square b square upon 2m this implies v is equal to h cut square b square upon 2m plus h cut square upon 2m into b raised to 4x square minus b square. This is equal to h cut square b square upon 2m plus h cut square upon 2m b raised to 4x square minus h cut square b square upon 2m. These terms cancel. This implies v is equal to h cut square upon 2m b raised to 4x square. So option B is the correct answer here. V is equal to h cut square b raised to 4x square upon 2m. There is another approach to solve this problem. So method 2, the wave function we are given is psi is equal to a e raised to minus b square x square upon 2. This is a very familiar wave function. The wave function for one-dimensional harmonic oscillator is m omega upon pi h cross the whole raised to 1 by 4 e raised to minus m omega upon 2 h cross x square. So if you compare the given wave function with the one-dimensional harmonic oscillator ground state wave function, you see that a is equal to m omega upon pi h cross the whole raised to 1 by 4, b square is equal to m omega upon h cross. This implies omega is equal to b square h cross divided by m. V is equal to half m omega square x square for one-dimensional harmonic oscillator. This is equal to 1 by 2 m. Omega square is b raised to 4 h bar square divided by m square into x square. So m cancel. This implies v is equal to b raised to 4 h bar square x square divided by 2m. For one-dimensional harmonic oscillator, ground state energy is E is equal to h cut omega divided by 2. So this is equal to h cut into omega is b square h bar divided by m, and there is a 2 here, so this is equal to E is equal to h bar square b square upon 2m. So using this method also you can find the answer.